Hey guys, so just before this video starts, just wanted to tell you all about the, if I look to the left slightly of the camera, or to the right, just because that's where the camera actually is, so just a quick apologise for that. Hopefully you enjoy the video, so carry on watching.
Hello there everybody, and so in this video I will be explaining to you the binomial expansion. Now the binomial expansion, as the title suggests up there on the board, is a way of expanding, okay? So we've got a couple of questions here just to get your practice going. So we've got 2x minus 3y all squared, we've got x minus y all cubed, and we've got 2 plus x all cubed. Okay, so with number 1 we've got 2x minus 3y all squared. What should we get for that one? Well, I assume you've done these already. If you haven't, then make sure you do these now, because I'm just going to put the answers up here. I have 4x squared, okay? I'm going to put minus 12xy. Don't forget the minus 12xy. And I want to add 9y squared. Okay, that's how we do 1a. 1b, how do we do that one? Well, it's a cubic this time around. So I'm going to get a cubic. I will start off with x cubed, funnily enough. Okay, I'm going to get minus 3x squared y. Yeah, and the other way around, so plus 3xy squared. And the last bit, I need to take y cubed away. For c, so 2 plus x all cubed, you should get 8 plus 12x. Yeah, plus 6x squared. And the last bit should be plus x cubed. Okay, so that's question 1. Okay, 1a, b and c. 2, so we've got minus 2x all cubed. Well, with our index laws we have to square them, we have to cube the minus 2 as well as cube the x. So minus 2 cubed is minus 8, and x cubed is x cubed, right? With this one, so I've got 3x all to the minus 4, so we can either do the negative first, or we can sort out the actual 4 first, and multiply by the negative. I'm going to do it all in one smooth, so I'll get 3 to the minus 4, x to the minus 4, but as we know everything is over minus 4, what can I finish off with? Well, I can finish that off with 1 over 81, which is 3 to the 4, okay, x to the 4, so I can finish it off like that. Okay, so that's how we can do that one. For this one, so we've got 2/5 x all squared. So 2/5 squared will give us 4 over 25 x squared. Nice and easy, that one. And d 1/3 x times the power of minus 3. I've got 27 over x cubed. You're not going to get that for yourself, but that's what I got. Alright, so question number 2. Question 3, we've got 25x all to the half. Well, with our index law, 25 to the half is the same as square root of 5. So I've got square root of 5 and then the square root of x. So I've got 5 square root of x. Straightforward. 64x all to the minus 2/3, however, so we can either do the negative or the positive first. So I've got the x minus 2 off there. So I'll put 64 to the 3rd times 2 minus. Yeah. So I end up with 1 over 16. Hopefully that one. Is that right? No, not right. Part C. To do part C, we've got 9 over 100x all to the power of minus a half. Okay, so I will end up with 10 over the cube root of 3 root x, should I say. Alright, so we can do C. For D, I've got 8 over 27 to the 4/3. Well, to put that as 2/3. Okay, to the power of 4 and x. Okay, so 2 to the 4, well that would be 16 over 81, is it? And the cube root of x. Alright, so a little bit of working out. Well, you don't need working out for those different things. 3D. Okay, so that's what you should know prior knowledge-wise. That should be one of the first things you ever covered in the M maths course, or the AS level maths course, if you are doing that. But next, we want to look at something called Pascal's triangle, which you might remember. So, let's get rid of this and move on. Alright then, Pascal's triangle. So, Pascal's triangle. Okay, so that's next. What I want you to work out in your head, if you can or do it on paper, is a plus b to the 0, a plus b to 1, a plus b to 2, a plus b to 3, a plus b, can we do one more? Can we do one more? Yeah, do one more. Well, a plus. Okay, so that's what we want to work out, each of these. Okay, so I'll pause the video and next week we'll do that. Okay, so you should have got a plus b to 0 and to the 0 is 1. Then, expanding this out, you've got 1a plus 1b. I'll put the 1s there for a reason, alright. Expanding that out, I've got 1a squared. Now, expanding that gives you the double reciprocal, so I get 2ab. The last one, 1 squared. A plus b cubed is that times another a plus b. Okay, so I've got 1 more than a cubed. What comes next? 3a squared b. What's next? 3ab squared, yeah. And the last one, do 1b cubed, yeah. So we should have got those. Now, a plus b to the 4 is that. One more, right? So I get 1a to the 4. What's next? 4a cubed b. Next. 6a squared b squared. It's getting complicated now. 4a b cubed, yeah. And finally, 1b to the 4. Now, what's the pattern here? Can we spot the pattern? Oh well. Let's have a look at that. Okay, so there is a pattern in the coefficients here. Okay? And 1, which is the whole reason for the 1. In other words, the numbers at the front have a pattern. Okay, and this is Pascal's triangle. It goes 1, 1, 1, 2, 1, okay, 1, 3, 3, 1, okay, 1, 4, 6, 6, 4, 1. This is Pascal's triangle, and we will use this a lot in the first couple of minutes here, and I'll move on to a button on your calculator that does this for you. Okay, and the button on your calculator that does it is something called NCR. Okay, which if you're doing AQA, which I will do a separate bit for, you have to make sure that you can calculate NCR using NCR problems. Okay, that's the only little bit that's different from other exam boards. AQA will like to calculate with NCR. Okay? That's where we're at. Okay, so you work out each number by adding to a buffer. So all the ones go on the x's, and they continue down the x's, and this continues to go on and on and on. You can go forever. It's unreal actually. I love Pascal calculators because it's one of these things where you can easily calculate it and find something missing. You might have heard of magic squares, or the magic triangles, where you might have a triangle and you're going to fill what's above and what's below. You might have done those lower down school, maybe year 7, year 8. Alright? But it's this kind of stuff that you will use a lot. So you might have had something like a grid like that. Something you might have 41, you might have 30, and you know that should be 11. Working out a little bit out, right? But it's using this idea of Pascal's triangle, so I draw a triangle there to try and help you. But the idea is, using Pascal's triangle, I can work out which bit goes where. Okay? And I'll be able to find out the coefficients of all my binomial expansions. So if I get a power exceedingly high, like a plus b to the 8, I can work out all the coefficients using the nice formula we can see that one now. So let's look at next. Okay, so I'll leave Pascal triangle there, we're going to use that in a bit. Put that over there. And let's crack on. So, this is Pascal's triangle, I'm going to leave that there. So, what I want is to find, an example, the expansion of, and the expansion that we're going to do is x plus 2y cubed. X plus 2y all cubed. Okay. Now you can work out what your coefficient should be from using this grid here, A and B. So what's your A going to be? A should be the X. The B is the Y. And what's the power? Some annotations I know which part of it. Take the Pascal triangle works on A. So, how will we do it? Well, we know the coefficient from A is a row. So if I write in 1A for a minute ago, you squared 2 and the y. You got 4y squared. Okay, no, 2y. Okay, so that's the only thing you need to calculate. So then in these now, the a and the b and the n. So we've got 3 lots of a squared, so 3 lots squared. Times b, so y. 3 lots of a. expansion, but can be really complicated if you get bogged down in the algebra. The algebra is where people struggle. But all I've done is just simplify from line to line. And that's it. That is your expansion done. A lot easier than doing this squared and then doing it cubed. Hell of a lot easier. Okay, now I think I've got one more for you. I've got one more for you. Let's get rid of that. I thought I had one more. Okay, so just checking what I wanted to cover with you. So I've got the coefficients. Of x squared. Which means the number in front of the x squared, okay? In the expansion of. See you next bit. 2 minus cx cubed is 294. Find c. So I want to find the value of c here. Okay, so how do we do that? Well, first thing you want to do is the x will be substituted for in the b. Okay, so using Pascal's triangle once again. So I'll sub in the a and the b. So I'll end up with your, what am I ending up with here? The 3ab squared, yes. Like so. Which is the expansion, so you should have expanded that and you should have got to that. If you have, that's great. If you haven't, make sure you expand that properly. So I've expanded that, and I want to sub in the 2 and the minus cx. So I've got the 3 lots, so the 2 and the minus cx squared. Okay? So I get 6. Now minus c times minus c will give us a plus c squared. Okay, so I get 6c squared x squared. Yes. Okay. So the coefficient of the x squared is 6c squared, so this bit here, I get the 6c squared. Well, what's the 6c squared equal to? It's equal to 294. So the c squared will be the 294 divided by 6, which means that c is equal to the square root of 294 over 6. Now, calculator, I got c is equal to 7. Okay, so make sure that you get plus or minus 7 as well. Okay, and that's it. So that's as far as I'm going to go in this part of the video. Now, if you want to watch the other parts of the video, you want to carry on watching the video that will come out after this. That's only part 1, that's using Pascal's triangle. That's basic stuff. Okay, I expect you to do that. That was a lead up to what we'll look at next, when we'll look at some binomial expansion problems. Okay, so I'll leave this one here, and I'll catch you in the next one.
Right then, so the next section is all about factorial notation. Now, factorial notation is something you might have seen if you've done further maths GCSE. I don't expect you to, but here we go. So how many ways can we choose all 5 of A, B, C, D and E where the order matters how you pick them? 5 choices for the first letter, 4 for the second, down to the last one choice available for the last one, right? So 5 times 4 times 3 times 2 times 1, which is known as 5 factorial. Okay, that's how you can do that. For the second one, how many ways can we choose 3 out of the 5 where the order matters? Or 5 for the first, 4 for the second, 3 for the third, 5 times 4 times 3. And we can do 5 times 4 times 3 times 2 times 1, so 5 factorial, over 2 times 1, so 2 factorial.
and we get 5 factorial over 2 factorial. Okay, so how many ways can we choose 3 out of the 5, where however now the order doesn't matter? If we are choosing 3 letters and the order matters, as in the second one we've just done, we would include all of those. However, if order doesn't matter, then we'd only include 1 of these. We have to divide the answer to part 2 by 6, or 3 factorial, as we have 6 times too many combinations. We have 6 there, we only need 1. So we have 5 factorial divided by 2 factorial times 3 factorial. If we are going to choose R objects from a set of N objects, then we have N factorial for number 1, number 2 would be N factorial over N minus R factorial, and number 3 is N factorial over N minus R, all factorial, R factorial. Okay. This number of ways of choosing R items from a group of N items is that one I've just read out. Okay. So this is also known as NCR, as a button on your calculator, which is what we'll look at in this section. So the factorial notation will be useful in the binomial expansion, and your calculator can be used to help. So 6 factorial is 720, 6 times 5 times 4 times 3 times 2 times 1 will get you to 720. Then we'll let you calculate AC3. Now on your calculator, if you hop to the NCR button, I don't have my calculator on me at the minute while recording this, if you put in 8, then the C on the NCR, and then 3, the number of ways to choose 3 objects from a set of 8 is 56. The reason why that occurs is because it is using Pascal's triangle, which you've seen in the first section, which I did on the board. This section will do it in PowerPoint, of course. Okay, so you should know what Pascal's triangle is and how it relates to NCR. So calculate 9C3 and 9C6 and comment on your answers. So they are both 84. Whenever you choose 3 from 9, you are essentially also choosing 6 from 9. Okay, they are the same. And that's all you need to know for the factorial notation, but as long as you know how to use it, you should be okay. Okay? Now, the binomial expansion formula, the one we're going to develop in this section, is the following. So we have a plus b to the 8, which is all of those brackets, 8 times. If I know that if I was to expand this, there will be some terms containing a to the 4, b to the 4. The number of terms will be given by the number of ways we can choose 4 A terms from the 8 available. Choosing 4 A terms will mean that 4 B terms are chosen automatically. We have 8C4 here, which is 70. So the term containing A to the 4, B to the 4 will be 70 A to the 4, B to the 4. Because this, let me get my pen, is choosing your coefficient. So the 70 is your coefficient here. Okay. So the binomial expansion allows you to expand powers of binomial expressions. The full formula for the binomial expansion, you don't have to learn it, but it is recommended to see where it comes from. So this is a plus b to the n is equal to a to the n plus n, choose 1 of a to the power of n minus 1b plus n over 2 a n minus 2b2, and so on and so on and so on. And we end up with n choose r is a to the n minus r, b to the r, plus a load of other terms plus b to the n. Okay? Where n choose r is n choose r, which is n factorial over r factorial n minus r factorial. So the powers of a decrease 1 each time, ending with 0 in the end, like so. The powers of b increase 1 each time, starting with none, so 1 there, 1 there, 1 there, and 1 there. The coefficients can be calculated using the NCR, which I have just put in red boxes there for you. This relationship is in the exam formula booklet that you are given in the exam, and you can refer to it, the binomial series. So you've got that formula, which is exactly the same, and it will tell you this section as well. Literally, as I wrote it above, is the same as what you get in an exam. Okay. So there's nothing different between the exam 1 and the one on the board there. Okay. This means that n must be a member of the natural numbers. It literally reads n is belonging to the natural numbers. In other words, a positive number or the counting numbers. Okay. So here's an example. Example number 1. Use the binomial theorem to find the expansion of 3 minus 2x all to the 5. We'll write out each term with correct powers and notation. This is before any terms out first of all. So we want to do all this. So work out the coefficient of each term. Be careful with your negative numbers. If you're not comfortable with your negatives, you need to practice those. This is summing in to that formula I did a minute ago. So expanding all this, get 243 minus 810x plus 1080x squared minus 720x cubed plus 240x to the 4 minus 32x to the 5. That's it. So this one says find the first 4 terms in the expansion of 1 plus 2x to the power of 10. We want the first 4 terms when you're expanding that, okay? So write out each term with the correct powers and notation. You only need to do the 4 terms here because that's what we're asking for. Do this before working out any terms. So 1 to 10, so on and so on in the formula. Work out the coefficient of each term, be careful. Got 1 plus 20x plus 180x squared plus 960x cubed. And they're your first 4 terms. Here's another find the first 4 terms, but find the first 4 terms in the expansion of 10 minus 1/2 x to the power of 6, all to the power of 6. Okay, so it's the same again, but this time we've just now got minus 1/2. Doesn't make a difference, just do the same principle, and the same thing over and over and over again. So I got 1 million minus 300,000 x plus 37,500x squared minus 2,500x cubed, and yes, the answers can be this large. So don't forget, if you were to do 10 minus 1/2 x times 10 minus 1/2 x times 10 minus 1/2 x, expanding it 6 times, you will see it will get very, 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 very large. Okay, so this is making it a lot simpler when you're dealing with this. The binomial expansion is not as tricky as you will see in this section. Now we'll look at solving problems with a binomial expansion. So for example, find the coefficient of x to the 4 in 2 plus 3x to the power of 10. So think about where the x to the 4 term will come from. Well, it will come this term being raised to the power of 4, so 3x to the 4, and that 2, which means that this one will be raised to the power of 6. If we've got 4 already, then we need 6 more to make the full 10 power in the corner. So we've got 2 to the 6 and 3x to the 4. As the power of 3x is 4, we are using 10 choose 4. And there you go. And I get 1,088,640x to the 4. And the coefficient that we want is just a number in front of the bit of the polynomial at the front. So it will be just this section that you want to write down. Okay? And that will get you all the marks for this question. Note that we could also have had 10-6 in this example. Also choosing from 6 are the same combination as choosing 4 from 10, as we've seen in the factorial notation earlier on in this section. So we want to find the coefficient of x cubed in 2 plus x times 3 minus 2x to the power of 7. Think about where the x cubed will come from. Every term of the binomial expansion bracket will get multiplied by the 2 terms in the first bracket. So how could we get the x cubed terms? I've got 2 plus x times 3 minus 2x to the 7. We would get them when the x cubed in the right bracket is multiplied by the 2 in the left bracket. The x squared in the right is multiplied by the x in the left, and so on and so forth. So we need to find the x cubed and x squared terms from the expansion and multiply them by 2 and x respectively. So we know what we need to do. Let's sort this out. Okay? So I've done 7 choose 3 of 3 to the 4 minus 2x all cubed. for the x cubed term. And for the x squared, well, that is just a power less. So we have to increase one and decrease the other. So I've got 7 choose 2, 3 to the all to the 5, and minus 2x all squared. So doing those, I get minus 22,680x cubed and 20,412x squared. So this one I have to multiply by 2, which gets me minus 45,360. And the other one needs to multiply by x, so it's just the power will increase by 1. So I get 20,412x cubed. And I have to add them together, and they give you minus 24,948x cubed. And that is your final solution. So the coefficient of x cubed in the expansion of 2 plus x times 3 minus 2x to the power of 7 is minus 24,948. So a nice concluding statement to conclude all your working out. Okay? So more tricky then. If g of x is 1 plus kx to the 10, where k is constant, and the coefficient of x cubed is 15, find the value of k. As before, think about where the x cubed comes from. So I've got the 1 plus kx to the 10. We need to write out what we need, so we get 10 choose 3 of 1 to the 7 times kx all cubed. I get 120k cubed x cubed, and we know that's equal to 15, so divide by the 120, I get k cubed is an eighth. Cube root, I get k is a half. And that's it. Okay? So it's that first section. If you know how to do the first bit, you can solve a simple equation, which you should know from GCSE, and maybe even lower down school. So, and you can easily solve that problem. You don't really need to do the extra steps to say k is the cube root of an eighth, because you should know what the cube root of an eighth actually is. You don't need to show that. But then you can easily solve. Okay? And that's how we do that one. So another one then. Write down the first 3 terms in ascending powers of x of the binomial expansion of 1 plus qx all to the power of 8, where q is a non-zero constant. So, if we write out the expansion with the rule which is directly above, at the top of your screen, we can expand that out nicely, and I get 1 plus 8qx plus 28q squared x squared. Given that in the expansion of 1 plus qx to the 8, the coefficient of x is minus r, and the coefficient of x squared is 7r, find the values of q and r. So if 8q is equal to minus r, and 28q squared is 7r, well, the way I've done this is I've kind of formed some simultaneous equations. So I've subbed in the minus 8q, because I know that's equal to r, and I've solved it that way. I'll expand, I get 28q squared is equal to minus 56q, add the 56q, and then divide by 28. Factorise it, so I'll get q lots of q plus 2 plus 0. And it also says in the question that q is a non-zero constant in the first part of the question, which means that q is not 0, can't be 0, which must mean that q is minus 2. And we can find the value of r, so sub in minus 2, you can sub it into 8 lots of minus 2. 8 lots of minus 2 will give you positive 16, okay? Because don't forget, minus 8 times minus 2 will give you the positive 16. Okay? If you wanted to, you could have subbed it in the other one. We'll still get the same answer. You just have to divide by 7 at the end. But you would get still 16. Okay? More complicated, but not too complex that you can't do it. The final section is binomial estimation. This is for the AS and the full A level. Okay? The full A level only video will come out after this. This is the last bit that you need if you're just doing the AS. So you can use the binomial expansion to find approximations for more complicated functions. The key part to understanding this is that if the values of x are small, it can be possible to ignore large powers. Makes sense, right? A couple of sections previously we had this expansion following this, and we expanded nicely, and we got that. Imagine x was 0.2. Let's look at the value of each term. 243 minus 162 plus 43.2 minus 5.76 plus 0.384 minus 0.01024. The values get progressively smaller. Why is that? Why do they get smaller every term you go down the list? Well, if we are approximating a calculation, we can ignore later terms since they will have less of an effect. So to find the first 4 terms of the binomial expansion of 1 minus x over 4 to the power of 10 in ascending values of x. Write out the first 4 terms and then simplify them. So, it's an easy. Use your expansion, this is part B, use your expansion to estimate the value of 0.975 to the 10, giving your answer to 4 decimal places. So compare the expansion with what you're being asked. So 1 minus x over 4 to the power of 10. And therefore, if they are the same, that means that this bit must be equal to this. So, if I rearrange it, I get 0.025 is equal to x over 4. If I multiply by 4, I get 0.1 is equal to x. This means that if we substitute x equals 0.1 into the expansion, we'll get an approximation for 0.75 to the 10. As so, substitute in, and I get 0.77625. If you did do that on your calculator, you get 0.776329. For dp is precisely 0.77625. Okay. And that is all I have for you on binomial expansion for the AS level. If you have enjoyed this, make sure you leave a like down below, and hopefully I will see you for the full A level if you are doing that. If I'm just doing the AS, thank you for joining me. We'll move on to another topic. And for the A level people, stick around because I have the A level stuff for you coming up in a separate video in a couple of days. Okay? Thank you very much for joining me once again.